about today is radical equations. These are actually pretty simple. You all know how to solve equations, right? Simple two-step equations. So like subtract 3, divide by 2, like that kind of thing. Okay, so we're going to have to learn to multitask, Mike. All right, so how do we solve a square root and radical equations? That's what we're going to be learning about today. We're going to learn how to do it graphically and algebraically. Okay? Are you ready? All right, let's look at the next page. We're going to graph the following square root functions, and we're going to solve the equations. Is everybody ready? Are we really excited? Wow, I feel the enthusiasm. Okay, so our first one, we have the square root of x minus 3 equals 0. So the way that we're going to look at this is we're going to look at it as two separate equations. We're going to think about this as a system. Remember systems of equations? Which, by the way, is what your next quick quiz is on, a system of equations. Okay? So what we're going to do is we're going to graph this in two pieces. All right, so go down to your f of x, f1 of x. We're going to put in the left-hand side of the equation, which is the square root of x, minus 3. Square root of x minus 3. Everybody have it? Okay. Then we're going to put in the right side of the equation. Who remembers how to get your function bar back? G. And you're going to put in f2 of x equals 0. Now, is that going to show up for you? Why can't you see it? It's on the x-axis. Good. Okay, so if I'm thinking about this as a system of equations, what am I looking for to find the solution? Where they intersect. Can I see it the way it is?
No.
Okay, so what I want you to do is I want you to click and grab your screen and just pull it so that you can see the intersection of the two lines. Do we have it? Can we see the intersection?
Mm-hmm.
Who remembers how to find the point of intersection? What do you think you're going to do? What button are you going to press? Menu. Now what? Points and lines. And intersection point. Very good. All right, so find the intersection point. You're going to go near the intersection. You're going to click on one line, click on the other line, and look what shows up for you. That's your intersection point, right? So, what does x equal? What's x equal? 9. So here's my solution. That's the solution to my equation. That's how easy this is. Your x value is the solution to your radical equation. How'd we do? Yes, dear?
You've just done that one pretty much in your head.
We're going to do it algebraically right now. Okay, so I want everybody to add in a notes page. How do you do that? Control-I, add notes page. And the equation was the square root of x minus 3 equals 0. Okay, so let's talk about how to do this algebraically. You're going to have to type this in. I'm going to write it because it's until my projector gets fixed, I can't see my piece. So, okay, so if I wanted to solve this algebraically, what would my first step be? Add 3 to both sides, yeah. So we get the square root of x equals 3. How do I get rid of a square root? Square, yeah. So I have to square both sides. Square root, or the square root of x squared is x, and the square root of 3 is 9. Hard? Your last step is to do what? Check. Now we checked it graphically. We know it's the right solution, but you can also check it what's the word I'm looking for? Oh, it's gone. By plugging in. Substitution. Okay, so we get the square root of 9 minus 3 equals 0. Square root of 9 is 3, so we get 3 minus 3 equals 0. 0 equals 0. So it checks. My solution is 9. And look how I wrote it. Look familiar? Those wonderful little curly brackets. Okay. All right, so that's algebraically. The first way we did it was graphically. And if on a test they tell you, okay, I want you to solve the equation algebraically, could you check yourself graphically? Yeah, absolutely. Why not? Okay, so there's no reason you should be getting these wrong if you can check yourself graphically. Go ahead to the next page. Here's our second equation. Now, how are you going to start this? What are you going to do? Put the left side down here, f3 of x. Put the right side in for f4 of x. Okay, so I want you guys to take some time. You're going to run through a few of these. You can talk with your partner if you get stuck. And I want to see if you can solve these graphically and then algebraically. Algebraically, you can do on a separate sheet of paper if you'd like. Okay, so take a few minutes to roll through those. All right, you should have done all the ones in between here. This one I want to look at together. A lot of you came up with the correct solution, but I want you to understand why this occurs. So if you have the square root of x plus 1, and you have 0, are they going to intersect? Yes, no?
No.
No. So if we're talking about a system of equations, are we going to have a solution? No, there's not going to be a solution. Graphically, we know there's no solution. So now we need to look at it algebraically. So here's my equation. My first step is to do what? Check 1. So we get the square root of x equals -1. Now what?
Square x.
Square both sides. We get x equals a +1. What do I have to do with this? I have to check it. This is why it's so important that you check your solutions, because it's not always going to work. Square root of 1 is 1, plus 1 equals 0. Does 2 equal 0? It is. Oops. Oh, now it's going to go all away. Oh, come on. Oh. Look, there it is. Does 2 equal 0? No. So our solution for this is the empty set. Okay, so it is very important that you check your solutions to make sure that they work. They won't always work. Okay? All of your square root functions are going to look very similar to this. They all kind of have that nice little curve to them. Notice they shifted up and down, left and right. We even had, when we had a -1, it looked like this, right? So this is our general form for square roots. Okay? I want to talk about cube roots now. So I want you to move ahead. And we're going to go to, let's see, what is this one? 2.2? 2. It might not be 2.2 for you if you've added pages, but you're going to go to the first cube root. Okay? Okay, I want to put this in the cube root of x minus 2. How do I put in a cube root? Control caret. Cube root of x minus 2. Kind of crazy looking, right? Okay, this is also the general form for all of these cubics. Okay, they're always going to have that little wiggle in them. Whether or not they're horizontal or vertical, that can all change. And we also have to put in our 0. Now, is our screen nice and pretty? Can we see the intersection well? So you need to move your screen so that you can see it. And then just like before, you're going to do your intersection points, and we get 8, 0. Any problems with that? All right, so let's talk algebraic. Cube root of x minus 2 equals 0. First step. Add 2. So you have cube root of x equals 2. How do I get rid of a cubed root? I have to cube it. I'm cubing both sides, and I get x equals 8. Does my graph match with my solution? Okay, so that's a graphical check. Our solution is 8. You okay with that? Okay. I want you to try a few more cubes, and then we're going to do some algebraic. So I want you to do 2 or 3 more cubes. You don't have to do the ones right in order. Jump around a little bit if you'd like, and then we'll go on to the algebraic. What's that? All right, so everybody's good with cube roots, right? Good with square roots? No problems there? I want to move on to the algebraic because there's a few things that I'd like you to see. So I want you to skip over to 3.7, which is going to be different for you. So that first solving square root equations when it's just algebraic and more graphic. Okay? So everybody here? Okay, so this is just solving equations like we were doing before, except we're adding a few different steps here. So what is my first step to solve? Subtract 2, good. So I get the square root of 3x minus 2 equals 4.
Square that.
Square both sides, yep. 3x minus 2 equals, good. 3x equals 18. X equals 6. Am I done?
Probably not.
What are you going to do?
Probably substitute.
Yeah, you got to check it. Okay. 2 plus 3 times 6 minus 2 equals 6. 2 plus 18 minus 2 equals 6. 2 plus the square root of 16 equals 6. 2 plus 4 equals 6. 6 equals 6. Let's check. How am I going to write my solution? Ooh, yeah, curly brackets. Ooh. It's kind of hard to do up here.
Yep.
Are you okay with that?
Yep.
Any big problems? Okay, let's get a little bit harder. Wait for you to get this in. Okay, so I want you to move on to this one right here. We have 2 times x minus 2 raised to the 2/3 power equals 50. Okay, so we know how to change rational exponents into radicals, right? We don't need to do that here. I don't want to make it harder than it needs to be. Okay? What's my first step in getting this solved? Dividing by 2. Can't distribute into something that's being raised to an exponent. So my first step is to divide by 2. So I get x minus 2 raised to the 2/3 power equals 25. Make sense? What's my issue? What do I want to get rid of? 2/3, right. Anybody have any ideas how I can get rid of it? Does this help? I want to raise it to something. What would I raise it to make it cancel? 3 over 2. Do you see why it's 3 over 2? What happens to my 2's? What happens to my 3's? Okay. So I get x minus 2 equals, you're going to put that in your calculator, 25 raised to 3/2 power. 125. Last step? Add 2. X equals. And what are you going to do to make sure that you're right? Check it. Now remember, our calculators have a very nice feature where we can store a number as x, and then we can just put in exactly what you have and make sure that it works. I would suggest using that feature. Okay, do you guys remember how to do that? Everybody here remembers how to do it? If you don't, please tell me so we can go over it. Does it work? How am I going to write my solution? In curly brackets, right? You don't write them in curly brackets, am I going to be upset with you? You could write x equals, but I prefer the curly brackets. Okay? Pet peeve. Okay, next page. Close, I already did that. Let's go to this one right here. Looks a little different, right? Okay. Are my steps any different? What am I going to do first? Minus 5. So you get square root of x minus 3 equals x minus 5. Our goal is to get rid of that radical. So we have to do everything that we did before in order to get the radical to disappear. Okay? What's my next step? I have to square both sides. What happens when I square this side? What do I have to do? Say it, Troy. Foil. You have to foil. Gotta foil it out. First, outer, inner, last. Remember? And you will get fast at that too. Yep, get everything to one side. So how are you going to bring the x over? And how are you going to bring over the 3? Add it, right? So we get 0 equals x squared minus 11x plus 28x, or 28, sorry. Now you have a factor, yeah? What are you going to get? Are my signs the same or different? And they're both going to be? Okay, so give me two numbers that multiply to be 28 and add to be 11. 7 and 4. So what are my solutions? X equals, oops, sorry. X equals 7 and, am I just going to assume that 7 and 4 both work?
No, you gotta check it.
You have to check it. Could you check it graphically?
Yeah.
Sure, you can check it graphically. You could also check it algebraically. Okay?
Would you want us to put 7 and 4 in the curly brackets or leave them?
Don't put them into the curly brackets until you've checked them. Okay? So we get the square root of 4 plus 5 equals 7. 2 plus 5 equals 7. 7 equals 7. That one works. So here's part of our solution. Let's see if the other one works. 4 minus 3 plus 5 equals 7. Square root of 1 plus 5 equals 7. Not 7. Sorry. My bad. 4. I'm sorry. 1 plus 5 equals 4. Does 6 equal 4? So here's your solution. Do you see why it's important to check? I'll test you on these ones because I want to know that you can foil
And check yourselves.
and check yourselves. Okay? How do we do with that, all right? Okay, homework number 12 is on your handheld. You have to download it from the site. Your weekly project corrections will be due next class, except for those of you that didn't receive them today. That'll be due the class after. If you were not here today, you need to make up the quiz on exponents. Okay, that's it.